Just have to forward outside registration. No. Okay. Can everybody hear me okay? Okay, perfect. I know we're getting started a little bit late. Just a few minutes to give you just overview of what we're going to be doing in terms of the logistics for the day. It's definitely a jam-packed day, so just to get you a sense for like who's all here. Look at all the people that came from all over the world that are here today. So woohoo, thank you so much for doing that for us. That does deserve an applause. And then some of the goals, this is all based on the feedback that you had provided us. You wanted more one-on-one time with each other. So you'll notice that this is completely restructured from the last time to give you as much hands-on time, like making sure that you're here, you're getting the help that you need. It's much more personalized, and you can figure out how to get the most value out of this day as possible. And most importantly, to be able to develop those relationships and meet all the brilliant people that are in the room today. So that's the ultimate goal. We do want to take a team photo at the end after the afternoon labs. If y'all can stick around so we can take a photo, that would be amazing. And by that time, you'll have your OpenXLA t-shirts because you'll have filled out your afternoon survey to give us feedback. Okay, so in terms of the day, it's broken apart into 4 different sections. The first part is just the keynote. We're going to have Robert, our distinguished engineer, gives you some high-level overview of OpenXLA and some of the awesome things that are happening there. We'll break into 4 different groups. We'll go to tutorials. I kind of walk you through that at the end, but that will be recorded. It'll be posted to YouTube on the OpenXLA YouTube channel. And then you'll have lunch, and the afternoon is just focused on lab sessions. It'll be partner specific, but we'll also have, don't worry if you don't have to stay with that particular table. We'll also have different tables with different experts, subject matter experts that you can also go to and get all the help that you need. And then the best part is when we'll have the happy hour in MP2. So we're excited about that. Just one more thing in terms of the tutorials, they're running twice. So the feedback that we got is you wanted it to be much more interactive. So that's what we're doing. We're running it twice. So it's a smaller group every single time, and you can ask the questions that you need answered. And then we'll do it all over again. We'll take a short break and we'll do it again. So you can switch between the different tutorials. And then the afternoon obviously is the lab session, and then we'll gather some feedback and then give you your OpenXLA t-shirts. Just to kind of orient you as to where you're at, you are in Mariposa Grove. This is where you're going to be all afternoon, right? So this is Mariposa Grove. And then for the tutorials, you'll either go right across, which is Walker Canyon, and that's in the blue arrow, or you'll go to Rosa or Bonsai. And then there's one more room upstairs that Kai will take you to. Sound of Music, perfect. All right, so these are the tutorials, and with that, I'm going to hand it over to the awesome Robert Hunt.
Thank you. Good morning. Welcome to our Dev Lab. Yes, I'm Robert. What can I tell you about me? I mean, I'm working on this for almost 10 years now. I mean, yesterday and the day before, we had a Google internal kind of XLA and Friends summit. I mean, there were almost like 400 people there. And now we have this August group of people. I mean, kind of proud of this. The growth of this thing is really cool, right? So thank you all for being here. And so today, in this presentation, it's about 20 minutes or so, maybe a little longer. I wear 2 hats. I start with a marketing hat, and you will probably see me fail at that. And then the second half will be more technical and more data and numbers and those kind of things. So let's start with the marketing side of things. So what is OpenXLA? First and foremost, a community. Here's a slide with all the groups and people and companies that are, somewhat related, interested, contributing, looking at, XLA. It's a large number of sizable number of groups and companies and whatnot, which also makes me kind of proud. And here's some numbers. I mean, the people here in the room represent about $10 trillion in market cap or evaluation. I mean, that's pretty solid. 5 of the top 10 custom AI accelerator companies use OpenXLA, which is also impressive. You can guess who those 5 out of the top 10 are. And 40% of the top 10 model providers use OpenXLA. I mean, obviously you can slice and dice those numbers in many different ways, but the way we did it here looks pretty good to me. And what is OpenXLA? Well, it's a high-performance ML infrastructure for the Gen AI era. I mean, we have a couple of areas that we want to focus on. Even we are production, hardcore production, but we want to be also very flexible for researchers, right? And it's both compiler researchers and ML researchers, and just like high-performance computing and scientific researchers that use this thing in some profitable way. It should be efficient for training. The scale of things that we experience in the growth of these models in training jobs is just mind exploding. Okay, and what you will see some glimpses of that in the other slides. What we all have to do to get to that scale. I mean, it's like, wow, these are amazing times. And OpenXLA, often in collaboration with JAX, has just really some fantastic features to enable that kind of super duper mega scale, right? It's amazing. And then, of course, for inference, we have to be pretty fast, right? Because, performance is money, and we do a lot of inferences, and these LLMs and other things are really, really expensive. So we want to really make sure that we are the best, bestest of all best, performance and production, teams for training, inference, and are flexible enough to really support research in all kinds of dimensions. Okay. I take off that marketing hat, I put on the engineering hat. What are we focusing on going forward? What have we been focusing on? First, our open source experience was not necessarily the best, right? But we really invested in that quite a bit, and from these statistics, you can see things get better. I think the top graph shows the number of contributions growing. The middle graph shows the time for these PRs to be submitted, which is in obviously, we put a lot of effort into that to speed that up because there was a major complaining point. And the bottom graph is contribution from a variety of companies. So things all point in the right directions. A lot of features are in the making for, what I mentioned earlier, to enable this super duper extra mega scale. I'm not going to go much into detail here, but it's really all about, right, how to distribute the model, the computation, the pipeline, the parallelism. You just name it, we do it all. And by the way, the slides we will open up after, and there will be speaker notes, and there's more details about those techniques in those kind of speaker notes. For GPU specifically, we have this new cost model-based, fusion algorithm in there. The cost model-based fusion algorithm is kind of cool because it allows us to pick and choose from the best solutions for different, domains or subproblems. I mean, for GPU specifically, there's like half a dozen different ways to generate code. Could be Triton, could be CUDA libraries, could be our own, could be Palas, could be this, could be that. And as it is typically in those kind of things, one is better here, the other is better there. And so if you build out this cost model and we drive fusion decisions by that model, we will just get the best of all worlds. At the same time, for all of you in the room, this flexibility will make it really easy for you to slot in your own code generation solutions. It's all sort of, by design. So, XLA, probably the whole machine learning stack, and probably all of you, and us included, it grew very fast, right? There's a lot of pressure on time to market, and it's a super exciting space, and everything is fast, and correspondingly, the software architecture may not necessarily be the very best one, right? So in order to make this more broadly applicable and usable, we really have a strong focus now on like clear APIs, well-defined interfaces, better modularization, higher code quality, you just name it, right? And there are blocks today that can be like separated out. The scheduler can be changed out, those kind of things. Stable HLR is a big focus. And so just wanted to convey to you here that this is a focus for us. It will make it easier for third parties to slot into this ecosystem. And that's what we all hope to do. Stable HLO is a big focus for us and quite successful. Kevin is over there. If you have questions, he did an amazing job there. It used to be that HLO is an interface to the compiler, and then it got wrapped into other MLIR style dialects. And then we finally realized how important it is to sort of like build a stable, sort of standard, not really standard, but more stable interface to this compiler, to machine learning as a whole, to reduce fragmentation, for the data center providers to reduce risk, deployment risk and those kind of things. So it's quite successful. It's fully open source. It's picking up. RFCs are being sent and approved. Contributors, a small number of contributors, which is good because it's supposed to be stable. But yeah, it's working really well. And if you haven't, you should take a look at that. Here's an interesting slide. XLA loves PyTorch. I don't know about you, but at one point I saw I have a sticker like it says Microsoft loves Linux. I still have that. When I saw it for the first time, I was like, so please, I don't know what to say, but it's not in this mindset. Okay, we do a lot of work with PyTorch. Here is a slide that shows coverage of like ops and models over time. And you can see that in just a matter of, I think it's the x-axis is weeks. Yeah, very quickly we ramp up, to full coverage. There's still work to be done, but what I want to impress on you here is that we're going full steam ahead and it's working well. As a result, here are our on-device ML benchmarks. So what happens here is PyTorch loads through XLA and some transformations onto TensorFlow-Lite, right? It utilizes these new compound ops that we just introduced in Stable HLO, and the performance results are pretty good. I mean, it's expressed in maybe like a weird way, but you can see that, compared to Onyx and compared to Executorch, what's the performance and how many of these models are faster, slower, or 10% faster or 10% slower, right? And green is good, red is bad. I think the green numbers look pretty good. It's actually quite impressive because, again, they've done this in a very rapid, very quick development time. And here is our, for GPUs, big GPUs, this is sort of like the reddish, orangish numbers are like a quarter ago, the green numbers are now. And what we want to impress here is like, well, we're not doing super well in performance for many models in this benchmarking suite. But progress, again, is rapid. We're committed. We're making this super duper extra fast. And our performance predictions, we have these development efforts. This is where we think we will be relatively soon. Maybe the 13% is, we kind of totally know how to get there very quickly. 40% is sort of what we believe is sort of the headroom that's in there for us on this Torchbench suite. And so this should be pretty good. I'm impressed. Supercharged GPU performance. Here is a anecdote as we benchmark ourselves against TensorRT LLM. And this is a Gemini model. There's many more. I just picked one, probably one that looks pretty good, but nevertheless. And what we see in this comparisons is that TensorRT LLM does really good in these OSS benchmarks, the Llama, and those kind of things. And but on our models internally, it does not, right? And this, I mean, nothing wrong with that. It's classic. Vendors want to sell their hardware with open source and spec benchmarks and those kind of things. But when we run those numbers in our own models or mixed precision models and those kind of things, it's not keeping up. And just to confirm that, for example, our Waymo benchmarks show similar patterns, right? They're like 20% or so just better on XLA than on TensorFlow RT. I meet Jensen tomorrow, and I want to convince him to use XLA in TensorFlow. Let's see how that goes. You may be happy to see that compile time has improved significantly for GPU, about 45%. That looks good, but not good enough. Compile time is still pretty horrible, and we have, it's a real effort to reduce compile time in memory. Memory is the first problem. There's some colossal memory blowout in there, and once we reduce that, compile time will decrease significantly, as we make those changes. It's a focus. It's a usability focus. It's on the map. And performance improved as well, which is good. Couple of ongoing developments that we have going on. Advanced capabilities even. Big focus for us is host offloading in general. Here is sort of a simplified picture of what we think that is with memory offloading. If you see the big green bar there, that's sort of a long living big tensor, right? That we compute in the beginning but want to use in the end. And the idea is just to offload it to the host, which has traditionally more memory, right? This frees up memory for those other computations, and then as you need it, a little bit before, you bring it back, and then it's right there, right? So this allows us to deploy much larger models on fewer pieces of hardware, and hence it's a pretty good thing to do. And of course, when you offload the memory, the next thing is you want to do compute offloading, right? And this is probably a little bit hard to see, but in one of those LLMs, what they are doing is, I should stay here, I believe, they rematerialize the activations, right? And what we want to do instead is we want to offload them, right? And as we need them, we just bring it back. And so as a result, very early performance results is already like 15% on both DENS and MOEs. And I expect a lot more performance from that. More importantly, of course, is that we can just deploy much larger models and less hardware. So if you look at something like system TCO, those kind of techniques are really, really meaningful. And this is the focus here is on GPU today, but it will come to GPU, as it is often the case, very soon. Alas. So Urs, our Google senior VP, set us the challenge. How do we enable our Gemini folks to help themselves if they have a performance problem within 24 hours, right? If they have to go to the compiler, compiler team is awesome, they will do their best, but it takes a while, right? And at the Gemini speed, not fast enough. And obviously, kernel languages such as Triton, very successful. And as is often the case, Google, we have our own, and we call it Pallas. Pallas is based on the JAX, ecosystem, if you will. It has a different model. While Triton has those kind of pointer arithmetic things going on, Pallas basically operates at the level of NumPy expressions. So to a degree, it's really more elegant, or if you come from the JAX world, like more natural. And it has all kinds of features. Yesterday and the day before, the Gemini folks, they do amazing things with those kind of things. Similar to what you just saw with this offloading and rematerialization and bringing things back and parallelizing and automatic pipelining, and it's all in there. It's fantastic. The kernels are fusible at this point. I think they're working on a schedule, make them schedulable with a proper timing model. It's really advanced kind of stuff, and we will focus on this quite a bit in going forward. So it's an amazing piece of technology coming out of research. And Pallas actually sits on top of Mosaic. And I have a graph here how this all relates. Pallas sort of, Python level, NumPy level expressions and those kind of stuff. The path I want to focus on here goes to Mosaic, and Mosaic can directly target our TPU low-level instruction set, but it can also go directly into HLO, and from there we can go to GPU and TPU, both at the same time. And so the focus obviously initially was on TPU, but they have a GPU prototype out there, which we call Mosaic GPU, unsurprisingly. And very early experiments are very promising, I want to say. So what is it, blue and cyano, whatever, are the Triton numbers for a number of for a number of different batch sizes. I actually right now forget what the model was, but you can see that, with just a super early prototype, Alice Mosaic GPU does really well. And because of those experiences, we certainly will pursue this further and actually hope to produce a meaningful alternative to Triton, right? Because Triton, I don't know who of you is working with Triton. It's awesome and really great people on there, some former Googleers as well. But they're mostly interested in AGI. Their interest is not necessarily in building a functioning Triton open source community, right? So there are challenges, and there are things that they probably will not support, and for that we have to have our own plan B, and that is Palace Mosaic GPU. Chardonnay. So one of the crown jewels in OpenXLA, in my opinion, is the SPMD and how we implemented this and how it works, and it's fantastic. But the problem is that it's sort of like baked into the compiler. And as like our researchers and Gemini folks want to play around with different distribution strategies and all that, not flexible enough. So they came up with a thing called PartIR, and we had the SPMD, and one is like research and one is production. And so they got together and they're now building this thing called Chardonnay, an advanced infrastructure for partitioning that allows you, to experiment with all kinds of stuff. They can apply priorities for like certain starting decisions and then propagate them properly through. Can be at the top, at the input, can be in the middle. There's like much better debuggability built in there. So it's fantastic. It is fully open source and generally awesome. So people are quite excited about this thing. How am I doing on time? Probably pretty fast. Okay. Just a few more observations, industry observations. Probably back the marketing hat here. XAI, after a careful evaluation, I have to say certain things. They decided to use XLA for both training and inference on their Grok thing, right? And they presented it at GTC, and we are very proud of that. Very good. Good choice. And here's the thing about Apple has officially adopted PJRT. In case you don't know what that is, that's sort of the take a subgraph, compile and run it interface. And because of Apple is on, we have a couple of hardware partners now, with Intel, Apple, ourselves, NVIDIA, using that interface, profitably. Pretty good. And finally, here is a community contribution from Alibaba, Torch ACC. And what the graph shows is it is as good as Megatron, which I guess is good. And this basically concludes my talk. I want to thank you all for being here. Thank you for contributions, interest, and looking forward to hearing more from you and working with you this afternoon.
Great.
Thank
Thank you,
you.
Robert. All right. So in terms of the site map, we're in Mariposa Grove. Walker Canyon is right across, and then there's Rosa and Bonsai, but we'll have the tutorial leads walk you there so you don't have to be disoriented. So depending on what you signed up for, the tutorial that you signed up for in the registration form that we sent out over the last 2 weeks, that's where you're going. So can I have all the tutorial leads like raise their hands? Can you all stand up so everyone knows who you all are? Perfect. So if you're with Kevin, he's going to take you over to Walker Canyon. That's Stable HLO. So let's have the folks that are going over to Stable HLO with Kevin kind of stand up and walk over there with him. And then if you're in Bonsai with Jane, do you want to raise your hand? And Sky as well. And then they'll lead you to Bonsai. And then for Rosa, Frederick. So make sure you follow Frederick over to Rosa. And then PyTorch auto sharding Kai, you're following Kai upstairs to the second floor. All right, see you guys back here at 11:45-ish for lunch. And then the rest of the afternoon sessions will also be here. Thanks so much, everybody. Okay, go ahead and go. You feel free to head on over there.
Do you have a list of which attendees should be in each room?
Yes, we have a tutorial registration form, but they're not necessarily following it.
Oh, okay. I was just
Yeah.
wondering because we have a guest that didn't have a name tag.
Oh,
So I was
okay.
gonna print him one, and just bring him to their room, but I didn't know where to direct him. to go.
We do have a registration form. It's okay. We can do it later.
Or I guess I just didn't know where to send him.
We'll have to look it up, but it also depends, did he actually choose to go there or not? Okay, hold on one second. Let me just exit this meeting.